All right, so here is our setup for our light experiment. So what we've got is this is an optic bench, and you can see that all of these little stands just slide onto the bench, and they can be tightened into place so that the lab is just set up. So what I also have here is these little holders where our Polaroid filters are going to sit on, like that. And so this optic bench just holds everything so that the lab is all together. This is our light source, and we have it hooked up here to a variable voltage source. And so when we turn this on, then our light is going to come on. I'm not going to slide that off of there, but the light is on when we flip there. So we've got our light source. We've got two Polaroids. One is going to end up going on this one. We're going to slide this together, and then the second one is going to go on the second holder. The reason that we have the two Polaroids is so that when they are turned at different angles, then the light transmission should follow Malice's law. So after our light source and where our Polaroids would be, we have this light sensor. So this is our light sensor. The entire thing just sort of has the wire through it, and in the end of the light sensor there is where the light is actually being sensed. It sort of looks like a little solar panel, actually. So it's collecting the light that's coming through to there. Now what we're going to be doing is setting this box over the entire experiment before we zero our sensor. So this is just basically blocking all the background light, the light in the room, any light from the windows. It is blocking it all out. So my light sensor is hooked up to a LabQuest Mini, which is the same sensors that runs the PhotoGates that we've been using, and that's hooked up to the program Logger Pro. And you can see that here it's reading 2.9 lux. And we don't want it to be at 2.9. So what we're going to do is just come in and zero the sensor. And so now this becomes the zero for our experiment. When I turn the light on with no Polaroids, then you'll see that it's going to kind of fluctuate a little bit, and it should settle in. So we're around 59 lux, so it's settling in. That's just because as the light bulb is coming on, the voltage is being applied to the light bulb. So it does fluctuate a bit just because of the voltage source, and it's a light bulb. It's not a super consistent source of light. But you can see that it's still fluctuating right around the 59 mark. So that's the light without any Polaroid. And so that will be your first data point, the intensity of the light. And so then what we're going to do is we're going to put one Polaroid on at the 0 mark. And I'm just going to slide my light sensor so that it's pointing at my light source. I'm going to put my box back on, and you can see that it's at 0 lux still. And turn the light back on, and we'll just give it a minute again to sort of figure out where it wants to be. And so you can see that it's basically fluctuating around 50 lux. And so that will be our first data point. So I'm still watching it a little bit. You can see that the highest it seems to be reaching is about 50.3. It's around 49.9. So when you get the data, it's not going to be exact because there is a little bit of fluctuation in the light bulb itself. but it is going to be as accurate as we can get it. And then I'll add the second Polaroid and turn it to the different angles. So just to show you the Polaroid, so first of all, we have our two Polaroids, and you can hopefully see that when I stack them and turn them, that it gets darker as the lines of the Polaroid are perpendicular to each other or lined up. So good applications for Polaroids are in sunglasses, actually. So they take the glare off of bright sunlight, essentially. Also for cameras, if you have a good DSLR camera, you can buy a polarizing filter to put over your lens. And with that, it basically just, if you have a really bright sunny day, you can turn it and you can bring down the intensity of the light with your camera as well. So these have lines on them, and so when I add the first Polaroid, I'm going to make sure that the line lines up with 0 on this particular holder. And then I'm going to slide this together so that it's holding. And then when I add the second Polaroid, I'm going to start it as well with the line at 0. But then I'm going to be turning it to 10 degrees, to 30 degrees, and to all the degrees that are mentioned in the lab data. You can see here the illumination is about 17 lux, and so when I put my box over to block out all of the light, you can see that it's still reading 2.9 lux. And so what we do is we go into here, which is the illumination sensor, and we 0 it. And so now with the box over top of my experiment, my lux should be 0. I just want to show you one more application of a Polaroid because they are handy as we study them. So I have this little piece of plastic here, and so with the Polaroids, I'll just show you again. These ones are lined up along the same line, and so then as I turn the Polaroids to 90 degrees, you can really see that it gets quite a bit darker. Now, they're not perfect Polaroids, and so there is a little bit of light still coming through there. If they were 100% perfect Polaroids, then absolutely no light would come through when they were at 90 degrees to each other. Okay, so what I'm going to do is I'm going to turn these at 90 degrees so that they're dark, and I'm going to take this and I'm going to put it in between. So that's not very spectacular because nothing's happening. But if I squeeze this edge, you can see that it lights up. And you can see what you're seeing actually is the stress on the material. So as you squeeze this, you'll see the stress on the material. If I turn it around and I put some pressure on the other side, again, you can see around the edges of my circle that this material is being stressed by the pressure that I'm applying. So because the Polaroids are blocking the light direction, when the light passes through this plastic object and then hits the second Polaroid, it appears different because the light is not, it's not perpendicular anymore, basically. And so that's just another application of the Polaroids.